Hello and welcome to a lesson for 5.5 for geometry. And here's some new vocabulary or some things you should know from before, hopefully, that will just come up again in this lesson. And make sure you're using those extra examples in your book for some help with your classwork problems, homework problems. So let's get started with 5.5. We're talking about inequalities in one triangle right here with this lesson. So let's first give not a definition, but kind of an explanation of two theorems. So rather than me writing these two theorems out verbatim, I'm just going to tell you what they boil down to, what it comes down to. So in any triangle, the smaller the angle, the smaller the side across from it is. Or in other words, the smaller the side is across from it. Probably a better way to say that. The smaller the side is across from it. If you want to see more on that, we're going to do this first example. We'll deal with these two theorems. But if you want to see more after that, these are theorems 510 and 511, which can be found on page 295. So write that down for me. And this goes with the word larger too. In any triangle, the larger the angle, the larger the side is across from it. So that also works. That's another way I could say that. So for example 1, this is what we're going to do for this example. Write the measurements of the triangles in order from least to greatest. You're getting 2 for the price of 1 here. We're going to do 2 examples within this example here. We're going to do one with the sides and one with the angles. So let's draw a couple triangles here. Make your triangles look like mine as best you can. We're not going to measure these precisely. These drawings can be done freehand if you would like to on this one, so we don't need to use the tools, but try to make your drawings look like mine as best you can. So we're going to say, start with a triangle like that. So this angle, let's get some labels here. This one we're going to say is 65 degrees. This one we're going to say is 70 degrees. And this one 45 degrees. Notice I didn't actually measure these things, but I am going to assume that those things are true. This is going to go with theorem 510. So while I'm thinking about that, let's write that down. This goes with theorem 510. And then over here, I'm going to draw a triangle like this. You'll notice it kind of looks like a right triangle. Maybe it is, maybe it isn't. I'm not telling you right now whether that's the case. But we're going to call this 6, 8, and 10. Over here, this goes with theorem 511. So theorem 510, given angle measures what sides are the longest and shortest. And theorem 511, given side measures what angles are the smallest and largest. So this one, the picture will now, I think, make sense. These people are jumping for joy in this picture. And over here, we've got, well, I couldn't do 2 E's because I can't use E twice, and I just didn't have an A, but this is kind of like my piece. So I'll give you the P symbol right there. So what would you say? Think of this. Think about this. Any triangle, the smaller the angle, smaller the side is across from it. What's the smallest angle over here? Well, I look at the picture. The smallest angle is clearly 45. So what's the smallest side going to be? It's going to be the side across from it, the side over here. So that is side OJ or JO. You could say that either way. We're not going to write the segment symbol above it because I want to refer to the numbers, the actual lengths of the segment. So OJ, no segment mark above it, would be less than. We're putting these in order. So this would be the lowest, this would be the smallest. What would be the next smallest? Look for the next smallest angle. So 45 is the smallest, 65 is the next smallest. So this side would have to be the next smallest. So this is jy or yj, you could say it either way. And then finally, what's the biggest angle right here? So what's the biggest side? It's the one across from that. So you could say OY, or you could say YO. Either way works. And then if you had to give a reason, let's put that reason underneath here. So I'll put that in parentheses. You may or may not have to do something like this, but this would be true since the measure of angle Y is less than the measure of angle. The next one was O, and then the biggest one was J. So since that is true, theorem 510 tells you that this is also true. And then over here, the same idea kind of in reverse. So look at the side lengths now. What's the smallest angle going to be? Well, it's the one that has the smallest side across from it. So here P has the smallest side across from it. CE is 6. So what's the smallest angle going to be? It's going to be the measure of angle P is the smallest number or degree measure for any of these three angles. The next one would be 8. So 8 is across from C. C and 8 are across from each other. So we have the next one in line would be the measure of angle C. And then finally, what's the biggest one? E is the biggest one. This is going to match up with the 10. So these would be in order from smallest to largest. So I'm saying by this is less than this, which is less than this. Notice my angle symbols. This is really important that we get this straight here. So angle symbols, kind of on like a 45-degree angle or so. This goes straight across. Less than signs do not look like angle symbols. Make sure that that is easy to tell. So these are not straight across. The bottom line for less than symbols not going straight across horizontally. This is true since CE, that was the smallest one, is less than PE, which is less than CP. Okay, so let's move on from there. And in this next one, we're going to have a couple of theorems. In the next couple of slides here, this one is the exterior angle inequality. Now we've dealt with the exterior angle theorem. This is based on that. So this is theorem 512. And you can draw a freehand triangle here if you'd like to. I'm going to use my tool to make mine look a little nicer. Let's see, I got good appropriate thickness there that will work. Okay, and this is going to be my exterior angle in the drawing. So draw something that looks like that. We're going to give these points some labels. This I'm going to call C, this will be A, this will be B. And this one, just for ease of talking about it, I'm just going to call that 1 rather than put an extra point out here. So this is angle 1 right here. So the exterior angles theorem said that measure of angle 1 was equal to the 2 across from it. So the measure of angle 1 equals the measure of angle A plus the measure of angle B. Therefore, if you think that through, this one would have to be bigger than either A or B, because these two do not have a 0 degree measure. They at least have to be something, even 1 degree or even 0.1 degrees or 0.000001 degrees. They have to have some sort of measurement. So that means 1, since it is the sum of these two, 1 has to be bigger than this one by itself, or 1 has to be bigger than this one by itself. That's what the exterior angle inequality theorem says. So this tells me, in other words, the measure of angle 1 is greater than the measure of angle A. Measure of angle A, there we go. And it also tells me that the measure of angle 1 must be greater than the measure of angle B. So this one, and this one added together equals the measure of angle 1. So 1 has to be bigger than this one by itself, and this one by itself. So let's say that. And if you do better with a sentence explanation, we're going to write down both here. So the measure of an exterior angle of a triangle is greater then the measure of either of the two non-adjacent interior angles. Non-adjacent interior angles. So what I'm saying again by that, this is bigger than this by itself, and this one's bigger than this by itself. And let's check out the other theorem in this one. This is just called the triangle inequality. This is theorem 5.13. So draw another triangle, make yours look like mine as best you can. So we have something similar to compare it to. We'll make an obtuse triangle here. Obtuse because this angle's measure is more than 1 or more than 90. All right, and this is going to be A, B, and C. And so what does this say? Triangle inequality. It basically says that you add up any two sides of the triangle, it's going to be bigger than the other side that you didn't include in that sum. So if I add AB plus BC, those two sides added together have to be bigger than AC. So let's write that down. AB plus BC is greater than AC. I hope that it makes intuitive sense too, because if you go straight from A to C, that's the shortest way to get from A to C. And then if you take this kind of off the beaten path route from A to B and then B to C, that would be a longer distance. From A to B plus B to C would be a longer distance than directly from A to C. So that's a kind of an easy way to remember that one. You could say that AC plus BC, if I added these two together, I walked along this path here to here, that's going to be longer than the path directly from A to B. So this one, AB plus BC, would also be bigger than AB. And in a similar manner, AB plus AC has to be bigger than BC. So for those of you that works for, great. For those of you that you're still like, I'm a little unclear on that, let's write down a sentence. So I want to see both ways written down on your paper. The sum of the lengths of any two sides of a triangle is greater than the third side. So pause, rewind, go back to any of that stuff that you weren't quite clear on, and refresh or renew your mind. That's not really the words I want, but make sure you got it. Basically, that's what I'm trying to get at. Make sure you got it before moving on. And then here, our last example. So I want you to think of kind of a door on a hinge as we do this one. I'm going to do some stuff down here to help demonstrate that door on a hinge idea. I wanted to say a triangle, not the triangle, a triangle has one side of 12 centimeters and another of 5 centimeters. Like an OM, there we go, CM, centimeters. What are the possible lengths of the third side? What are the possible lengths of the third side? And let's write the whole thing out here. I want to write smallest possibility. That's going to go over here. And over here, the largest possibility. So there's going to be a range of values for this one. Largest possibility over here. You may be wondering, what are you talking about? Why is there going to be a range of values? You do not have to color code this, but for the sake of just making it easier to see what's going on, I'm going to color code it here. So if you really wanted to, you could. But the smallest possibility, I'll draw something as best I can in a 5 to 12 ratio. So this is going to be my longer side, and I'll use red as my shorter side. And let's see, that would be about half, so I'll go a little less than half. That looks pretty good. Okay. So for my smallest possibility, pretend the red part is kind of like my door on the hinge. So I want to think of this in this way. So you can draw this out the way it is right now, but I want to just imagine for a moment that this is rotating on a hinge. So I could be thinking of this, and let's draw this here first. So we've got, this is 12 centimeters down here. Again, this doesn't have to be in a different color, but you can do that if you want to. And this is 5 centimeters right here. So this door, it could be closing. Could be getting closer and closer to that. Draw that little arrow in. It's on this hinge, so it's kind of like in a circular path, you might say. It could open farther, but that's going to be more of the largest possibility. If you open this door more and more and more, the triangle would get bigger and bigger and bigger. So I want you to connect here this last side. This is our third side of the triangle. If I close this down a little bit more, let me see if I can do that effectively here. So imagine this is closing. It's the door on the hinge. It's closing, it's closing, it's closing. It's going to get closer and closer to that smallest possibility. So if I connected this now to there, it's still a triangle. If I kept closing it, and closing it, and closing it, and closing it, it's still going to form a triangle right there. So if I connected this to here, still got a triangle, but if I take this and go all the way down there, go right on the line, I no longer have a triangle. I just have a straight line now. So I need to have at least a little bit popping up right there. It could be really, really small, but the idea here is to say, okay, if it gets extremely close, what's the, in essence, what's the limit of this? As I get really, really close here, what's the closest it can possibly get without actually touching it? Well, 12 minus 5. Anything bigger than 12 minus 5, this would be 7 left over for that. For anything bigger than that, so we can't go exactly 12 minus 5, because then you don't have a triangle anymore. But anything bigger than that will do that for us. So, in other words, what do I want to do here? So I'm just putting this back to where I started. What do I got? It all boils down to this, or it's as simple as this. The smallest possibility is 12 minus 5, which is 7 centimeters, but not thinking that exactly. I'm saying anything bigger than 7, because 7, if it was right on the line, you would not have a triangle anymore. In the same way, in the same manner, if I were to, let me just copy and paste this right here, make a duplicate copy of that. So I've got the same sides over here, but this time, don't draw this quite yet. This time we want to extend this out a ways a little bit. So let me get that for you all set up in a second. There we go, that's better. And so I want you to think now, this is as it's getting opening, or as it's opening bigger and bigger and bigger. So this, imagine this kept going open this way, farther and farther and farther and farther and farther. This red line now has gotten to this point. Could it keep going farther? Sure could. So I'm saying let's continue this way. As it opens more and more and more, that door on the hinge, this third side here keeps getting bigger and bigger and bigger. What's the largest possibility? Well, this is 12 right here, 12 centimeters, and this is still 5 centimeters right here. And so as it opens more and more and more, it's going to keep getting closer and closer and closer to 12 plus 5 now instead of 12 minus 5. So what do we have going on here? 12 plus 5 equals 17 centimeters. Can it actually be 17 centimeters though? No, because then that means it's perfectly straight, and with a perfectly straight line, no way you can have a triangle with that. As long as it's just above that, then you could connect that point to the point right here and have an actual triangle. So let's all that I've been saying there, let's actually write it down in a succinct way. In order to make a triangle, the sides cannot be perfectly straight. And by that I mean the two sides that you have here cannot line up in a perfectly straight way. So the sides cannot be perfectly straight. With each other, we'll say. So they cannot be perfectly straight with each other. Thus, the third side and we'll call it x. We'll say this is x up here. We'll say this is x here. The third side x must be, and you could write this in a couple different ways. You could write it in a kind of a worded out way, greater than, I think I just made that phrase up, worded out way. You can write this in words. So it's greater than 7 centimeters, but less than 17 centimeters. Or an equivalent way to say that, more in an algebraic expression type way, would be that 7 centimeters is less than x, which is less than 17 centimeters. Notice I'm using my units here since those were given to me. So you could say it like this. So we could box that in. I would be fine with it worded like that. Or you could say it like this. Either way would work just fine. So that door on a hinge, the red part is kind of like my door here. Opening up, the farther you open it up, the closer it gets to 17. The more you close it, the closer it gets to 7. Can't actually be those things, but we use those two numbers and write an expression like that. Hope you found that helpful as you tackle your lesson, your classwork on 5.5.